Gamesalad Guru and another tutorial using Gamesalad. So in this video, we're going to look at the first of the new features in 1.25. And what we're going to do is we're going to go ahead and look at the center of mass, which was introduced in a earlier version of the current version of Gamesalad. But we're also going to look at the new added features that enhance that center of mass adjustment feature, which is called the pin. So now we're going to go ahead and we're going to look at how we evaluate the center of mass, what it does, what it's used for, and how to calculate it. And then we're also going to look at and discuss the pin function. So I went ahead and grabbed one of the pinball Croutons, and we have the little paddle actor here. And so let me drag that on the scene. So let's go ahead into the actor, and let's just take a quick look under the Motions tab. And we have this new section called Center of Mass that you've probably seen. And we have an X and Y position related to the center of mass. And then up here, we also have our general position attributes that tell us what the position of the actor is on the scene. Now, what I need to explain to you is that these two particular sets of attributes, the position attributes and the center of mass attributes, are two different ways that they're evaluated in the Box 2D engine. So in the Box 2D engine, they're separate because it relates to rigid bodies and all this stuff I'm not going to get into. But what you need to understand is these are two separate values. And these two separate values record and perform differently when you're using them. So first, let's go ahead and let's just look at how we calculate center of mass in an actor. So in an actor, we know that the relationship to an actor, that its position information is based off this center mark here. And so this center mark is where we gather a couple things. One, in relationship to the whole scene, this 0 or center position tells us where on the screen this actor is placed. So if I move it around all the time, my X and Y positions will be related to this position here, not any of these other positions. So when we do an offset conventionally with an actor, we go off this 0 point. Because everything we do in relationship to the actor itself, not the actor in the scene. So if we want to move positions around, we want to offset the position of an actor off of its center, which is the conventional way that things are measured. We have to go in relationship to the actor when we add our offset numbers. So let's look at it this way. Let me explain it this way. In relationship to this actor and its size, so this actor is 273 or 74 pixels long from end to end on the x-axis. And we know this is the x because of the way this handle goes. This is the rotation handle, but this as well gives us the orientation of the actor and how things are measured. Everything works off the direction of this handle. So this is the x-axis on an actor this way, and this is the y. And it doesn't matter which way you rotate it in relationship to the actor. This is always the x-axis along this line, and this is always the y-axis this way in relationship to an actor itself. Okay? Not in the scene. And so when we have this position, okay, and so this actor, 274 pixels, we don't measure an actor in Gamesalad that way. So in other words, it doesn't start at one end at 0 over here and then go over to 274. 0 is actually in the middle here in relationship to an actor. And so when we count in Gamesalad, this actor is actually divided in half right here along the Y and in half across the middle here in the center. So this is absolute 0 here. So when we go this way to the right, okay, we're counting up positive numbers, and this is based on the direction of this arrow here. And so we're counting from 0, so half of that would be 137. So we're counting 137 pixels from this center point to this edge. positively. And then if we were to go back this way and count, we would actually be counting in negative numbers. Since this is 0 and we're going back the other way, we'll be going back in a negative value. So from 0 here in the center back to this edge is negative 137 pixels. And it's the same way for the Y. When we go up, it's positive pixels from this center to this way, and it's negative pixels from this center down to the bottom. So if we want to do a rotation on here, and let's say I wanted to rotate from somewhere in the middle of this pinball paddle, and let me go ahead and just grab this little, I took the ball out of here, but it just gives us an idea so we can actually see how the rotation's forming as a reference point on the scene. So let's say I want to rotate so this fits right into that spot, and I want to be rotating around this general area. So I've calculated it, and this is roughly from center 100 pixels negative back to this point right here on this actor. So let's just go ahead and throw a rotation behavior in here and just look at this for a second. So let's just look under the physics tab, and let's just click fix rotation, and then we'll go over the behaviors. And I'll just grab a regular general rotate behavior. And then we'll go ahead and, without doing anything, we'll just see that now we're rotating from the center position. Not the X and Y position, but we're rotating from the center COM. These are two separate. Position and COM are, think about it as two separate entities on the actor. Okay? So when we change the COM, we actually won't be changing the position. We're just changing the place at which the actor rotates from. And so let's go ahead and come in here, and let's go ahead over to the center of mass. And so I want to rotate on the x-axis, and I want to be rotating back at this point, so it's a negative 100 pixels to get back this way. So in the x center of mass, I'm going to go ahead and say, give me an offset on my rotation of negative 100. Okay? And so let's go ahead and preview that. And so you'll see now that I'm rotating off this position back here, which is negative 100 pixels back. And that's fine. I can do that, no problem. And so let's just grab a couple things so I can show you the difference. Let's grab some display text. And I'm going to go ahead and let's just grab a display text here. So let's display some text. And actually, you know what? Let's move this outside so it's not moving around on you so you can see it. So let me just quickly make a couple attributes here. Let me make a couple of real attributes. All right, so we're going to just look at those, and then let's go back to our actors, and let's just do some quick change attributes or constrain. So I'm just going to constrain this is the ball's X position to that ball external attribute. Oh. Position. There we go. And then let's go ahead into our paddle, and let's grab another constraint, and we'll go ahead and do the same thing. Okay. And so now let's just make, I'll just do it in one actor and use an offset. So let's grab a couple of display texts. And since the ball is blue, we'll make that one blue. And we'll grab game.ball. And then since the paddle's red, we'll grab that and we'll say game.paddle. And then we will go ahead and offset this down. We'll go negative 40. Okay, excellent. So let's grab our little actor here and we'll stretch it out so we can see the numbers. And let's go ahead and hit preview. And so we're going to see that we're way different from the X position. We can see it's, we're out here at all these different places, rotating around out at 500 because we're offsetted, remember, 100 pixels. So as we're rotating, this is the X position out here. It's changing. So the ball position is a steady 420, so we can see everything out here is up basically 100 pixels off as we go around. And that's because we're still looking at our position based off this center object right here. So if I were to, let's do it this way. So this is 420 here, right? So if I'm going to set my actor, let me say go ahead and put this X at 420, right? Because you can see we're at 518, right? That's our position. So if I say, I want now my actor to be at 420, what we're going to see now we're not actually at 420. The center position right there, see? Let me see if I can pause it. Boom. Okay, so now you see that the position that I initially set, which would be the center of the actor, is right there on that ball. So when you're doing comms, you have to understand that your position is going to be different because you're doing an offset on the rotation. You're not doing an offset on the actor's position. The actor's position and the way Box 2D measures things based on the structure of an actor, you're only changing the representation at which motion can be applied to a spot. You're not changing the physical position of the actor. You're just fixing the actor where its center of mass, and center of mass is where all the physics engine is told where to rotate around. Okay, it's a fixed position of which movement happens, not actual position on the rigid body, which is out here. These are two elements that Gamesalad cannot merge because of the way Box 2D is structured in its environment. And so what you get is this is your position, okay, right here. This is the position we're going to be fixed at, so it's going to move everything. So what we have to do in our code is take into account when we're setting our position, we have to take into account our offset. So let's say we wanted to have the actor be placed in the right position. So then we would go ahead and let's go ahead and grab a change attribute, and let's just say change your self position X to, and let me just look at let me line this up the way I had it, like that, and then see where that position is. So that X is, we'll just go with 520. So that X is 520 there. And so if we didn't have a reference actor and we wanted this to line up, we would take this position. And so this position is 420. So we would say, and depending on how we're going back in this position here. So if we did it like this, let's do it like this. Let me open this up here. And so we want the Y position to be the same. So let's go ahead and grab a change attribute, and we'll change the self position Y. Okay. So let's go ahead and just look at this. And we got a self position Y of 450 and an X of 520. So we want in this self position Y to be 450. Okay. And so then we want the self position X. And so we want the self position X to be, we've got 520, okay, but let's say we're working off that center position. So we got 520. So let's say we wanted it to end up here at 520. So we would take this position, 420, and then since we have a negative number, so let's do it this way. So we do self position X to 420 plus center of mass. So if we go ahead and move this, we should, minus, sorry. We got to minus that, minus center of mass. See, and that's going to put us into the proper spot that we want to be. So now you can just do a equation to make sure your actors are placed in the proper spot. So let's say that I was going, since I have the X position of this actor, let me show you how to do it with a pre-placed situation. So say I wanted this actor to move to that position, right, where I have the ball. So I could just simply, since I've got it exporting to external variables, I can say basically game dot ball minus center of mass of my actor will put my self position X in the right spot. So probably because this is firing. Let's see. Bet you if I switch the layers. Let me fire this first and see what happens. Yep. Okay, it was just the way that was firing. So this is where code, is critical when you're setting this stuff up. So now I'm rotating over that actor. So what I would do, let's say in this situation, I can't have my layer order like that the way I want. I would just go ahead and delay this change attribute by a code cycle, which is all we're looking for. So let's go ahead and say after 0.03 seconds, run to completion, do this, and then do that as well. Might as well lock them both together. And then we can go ahead back to our layers, and we can put the ball above here, and we should get a proper call. There we go. So now you can see just how code order, I have a video on code order that can show you how different elements work, and how you can see how you need to structure everything, because the way the code fires so fast, what was happening was the code in this actor was firing before this ball was reporting to my game level attribute, which was forcing me to go over here off 0 because that was the value. So it just shows you how fast 1.25 is actually doing things. Normally in the past, that stuff would all keep up. So this build is, for some people, this might break some of your projects, not intentionally. This might, if you've got hinky issues, watch your code order, okay? Because this is a really good, fast build, really good scanning and everything. So let's go ahead now and let's talk about the pin function now that we've seen how to offset. And if you wanted to rotate the other way, we would just put a value of, let's go right out on the edge, 137, positive number. And this is going to cause us to rotate right on the tip. See, just like that. So, and you could adjust the Y the same way. And this is how the center of mass works. So now let's go ahead and let's look at this function, this right down here called pin. So now what pin does is it essentially allows you to constrain an actor. So let's look at this. So I have a movable fixed rotation, and I have this actor that's rotating, right? So let's take this ball. Let me get rid of this. I don't need this anymore. So let's take this ball. Let's go into this actor. I'm going to get rid of all this stuff. And I'm just going to let it rotate in the middle here. And so we have that going around. And let's go ahead and just make a slight offset here. So we'll go ahead and we'll make a 50. Let's just go 50. This will give me a little more tighter circle so I can kind of, there we go. And so let's go ahead, and what I'm going to show you is I'm going to show you what happens when you take an object and do the center of mass and then you strike it. So let's go ahead and go in the ball, and let's go ahead and just grab a collision. And we'll say, collide with the flipper. And then let's just grab some let's just grab an accelerate behavior. And I'm going to go ahead in this direction relative to scene, and we'll put it at 100. And we'll go ahead and we'll just put this right over here, and we'll let it collide with that. So you're going to see, you know, everything's kind of moving around everywhere. Even though we change the center of mass, it doesn't. And so what happens is you can't use a traditional constraint. So let's go ahead and say we constrain the position. So if I went ahead and say constrain self position X to, let's open this up. So let's constrain self position X to, see, I'm probably out there at like 600s, like the center. So let's do it that way. So let's constrain the position, and then let's see what happens. So now you see everything's all funky, okay, because now the way you're using center of mass, it throws everything off, because now we're constraining to the position, and we're trying to rotate the thing, and the X position is going to move. This is why these two things are separate entities, okay? So in the old days, what we would do is we would do an offset, and then we could constrain the position, and then we would do some math for the rotation. And so now we don't have to do that anymore. We have this new variable called the pin function. So if I go ahead and check pin, and I'm going to go ahead and fly this ball at this, you're going to see now the actor doesn't move off. It's essentially constrained to this position. So now we don't have to do the typical constraints that we used to do. And this pin function works specifically for offset of the moving characteristics of where that center is placed in Gamesalad. So now we rotate off that center, and now we're actually pinning the center of mass to a certain spot. So we're actually able to pin the position of the actor, or not essentially the position, because the position doesn't change, but we're actually pinning the spot at which, when collisions happen, it's not going to move off that location. It's not going to adjust. So we're actually pinning that spot in the rotation area here where we're offset. So we're pinning our offset in relationship to everything in that spot. And this allows us to have collisions in this. Now, center of mass pin does not completely, in every circumstance, I would probably say 90% of the times, you can use a pin and keep a collision intact. Pin, because of the way it works, and the way the physics engine is, you can, by a collision, force something slightly off its pin. So in other words, right, in physics, when a force meets an unstoppable object, right, we have something's got to give. And so in the pin, let's say we had this ball here, and we were going to rotate, and this is not movable. I mean, you can't budge this. If we did that, this pin here is going to get knocked. It will get knocked off its location. It will not stay completely constrained. It is not an override constraint. It's a pin, and it's part of the physics engine. When you do a constraint, you're overriding the physics engine. So what you have to understand is, when you're using common pin, that it has to be collisions between two actors that will give. In other words, if you're pinning something, anything else it comes in contact with has to be able to give way to the actor that you're calming and pinning and then colliding with. And so the main way to do that is now that we're in the physics engine, right, is that either one, the velocity and the force is greater than this one, or two, the density of this particular actor here is greater than the other actor. Because, right, if a lighter object hits a heavier object, the lighter object moves. So we have to remember, when we're working in the physics engine, the laws of science, or the laws of that Isaac Newton put in place in relationship to how things work in the physical world, in physics, gravity, all those things, they all come into play. Okay, it's real world physics. And so in the real world, a heavier object will not a lighter object will not displace a heavier object. This is true in Gamesalad in relationship to when we're working in the physics engine. So with the center of mass and pin are functions that work inside the physics engine. So if you want to escape the real world physics in Gamesalad, so if you're going to pit two forced objects or two hard objects against themselves, okay, and you want them both to remain in static positions, then without turning off the velocity, because we could make this rotate around, and when it collides, we could get rid of the force that's going on here. There are a lot of different ways you're going to do things. And so if you wanted this to swing around these two objects and not move when they hit each other, you would either have to take the velocity off, have a higher density on one of them would still move. But if you would want them both to be fixed when they collide with each other, then you would have to take them out of the physics engine. And so that would mean going back to conventional constraints or programming things in your code that's going to remove the intensity. So you would say when you would have to program this to come around now when it collides with this. If you didn't want either one of them to move, say this was like a dial or something, and I wanted this to rotate around, and when it came to this spot here or touch this object, I would want it to stop. Then I need to code that into my game. So I would need to say shut off whatever move to or rotation behavior or whatever, and then also I would want to change the velocity or freeze the rotation at that point, or do whatever I need to do in my code to stop the action of the physics engine. So you're not going to have this thing work by trying to just do it in the basic physics, because, well, that doesn't work like that in the real world, and that's the whole point of real physics in Gamesalad. So when you're using the pin function, you need to understand that the pin function actually works inside the physics engine. So you're subject to all the rules of the physics engine. If you want to not be in the physics engine, then you need to use interpolate or constraints or whatever to manipulate your actors so that you take them out of the physics engine and you can do things that aren't relative to real world physics. And so this is basically how we use the pin and com function in Gamesalad together to fix objects. And so remember that when you do a move, so let's say I wanted this right to move based off of this X and Y position, you're going to need to make sure that you add the offsets in there, or it's going to move based off this center position. So any move to behaviors or whatever you do, you need to link them in there with a function that links them to the math of what you have set for an offset, so that everything moves based on what your offsets are. If you want them to move around based off of this position here, because movement in relation to general moving and all that is still going to go, because you're manipulating where the actual location of the actor is still going to be off this center position. So you need to make sure that you do those equations in your actors, that you have offsets in to move them properly. Okay, so anyways, this is Dave, the guru. I hope this helps you to understand how to use the new pin function and the center of mass function in Gamesalad. I'll see you in the next video.